Hey everyone, welcome back to my channel. Today we are diving into an interesting problem related to a linked list called finding the minimum and maximum number of nodes between critical points. Let's break this down step by step to understand what we are dealing with. Let's understand the problem statement. Imagine you have a linked list which is a series of nodes where each node contains a value and a reference to the next node in the sequence. In this problem, we are particularly interested in identifying and analyzing critical point within this linked list. So what exactly is a critical point? A critical point in a linked list is defined as either a local maxima or a local minima. Here what that means. A node is considered a local maxima if its value is strictly greater than the value of both the previous node and the next node. Conversely, a node is a local minima if its value is strictly smaller than the values of both the previous node and the next node. To visualize this, think of a graph where the value of the node are plotted on the y-axis and the position of the node on the x-axis. A local maxima would be a peak and a local minima would be a valley. One important thing to note is that a node can only be a local maxima or minima if there are both a previous node and a next node. This means the first and the last node of the link cannot be critical point. Objective: given the head of a linked list, our task is to find two values: minimum distance, the smallest distance between any two distinct critical points; maximum distance, the largest distance between any two distinct critical points. If there are fewer than two critical points in the entire linked list, we should return in the list -1 and -1. Let's take a look at a simple example. Here the input head equal to 5 3 1 2 5 1 2 and the output is 1 and 3. In this case there are no critical points because we only have two nodes, hence the output is 1 and 3. To solve this problem, we have to follow this step in our code. First, edge case handling. In the list has fewer than 3 nodes, return -1 and -1 since no critical points are exist. Identify critical point, traverse the linked list and identify the position of all critical points. We then third, calculate the distance. If we have fewer than two critical points, return -1 and -1, otherwise compute the minimum and maximum distance between any two critical points. Let's write the code. If node head or node head dot next or node head dot next return -1 -1. Critical points create a list blank list critical points previous equal to head, current equal to head dot next, position equal to 1, while current value is dot next if current value greater than previous dot value and current dot value is greater than current dot next dot value, or current dot value is less than previous dot value and current dot value is less than current dot next dot value. Critical points dot append the position previous equal to current, current equal to dot next, position equal to 1. If length of critical point is less than 2, return in the list -1 -1. Minimum distance equal to in the float max distance equal to critical points -1 point 0. For I in range 1, length of critical points minimum distance equal to minimum distance critical points of I critical points I minus 1 return minimum distance and max distance. This code starts by handling edge case, then it traverses the link, linked list to find the position of all the critical points and store them in the list. Finally, it calculates the minimum and maximum distance between these critical points and return them. Let's run the code. Okay, there is some mistake. Okay, accepted. I hope this explanation clarifies the problem and the solution approach. If you have any question or need further clarification, feel free to leave a comment below. Don't forget to like, share and subscribe for more coding tutorial and problem solving videos. Uh, Let's submit the code. Okay, it also accepted. Thanks for watching and happy coding.